Okay, so on this question, we've got two big fractions and we're dividing them. So whenever we're dividing, we've got to change to multiplication. I think you know that. If you think about like 10 divided by 2 is 5, that's the same thing as half of 10, right? It's also 5. So I'm just proving that dividing is upside down multiplying. We already know that, right? Dividing is upside down multiplying. So whenever you have dividing, you're just going to keep the first fraction, change the sign in the middle to multiply, and flip the fraction on the right, aren't you? That's what this little example shows, huh? We flip the fraction on the right and change to multiplication. We keep the first number the same. All right, so let's do that. Let's come on down and make that happen. So this is going to become times, and then the first fraction doesn't change at all. 2x squared plus 5x plus 2 over x squared plus 1x minus 6. But the second fraction is going to flip. So the 2x squared minus 5x plus 2 goes in the top, and the x squared plus 3x plus 2 goes on the bottom. So we keep the first one, change to multiplication, flip the one on the right. Now we've got a multiplication problem. So now we can start canceling. So x squared cancels x squared, x cancels x. No, you know better than that. You can't do that, right? You can't cancel added, subtracted items. So that's the next issue. I'll write it up here. We cannot cancel added, subtracted items. You know that. You've seen that, right? If I give you an example, 2 plus 4 over 2, that's really 6 divided by 2. It's really 3. If you cancel the 2's, now it's 4. That just shows it's wrong. You cannot cancel added, subtracted items. If it was times instead of added in the middle, it'd be okay, because now it's really 8 over 2, right? 2 times 4 is 8. 8 divided by 2 is 4. Now it's okay to cancel the 2's. It's still 4. So we can see the problem is the adding or subtracting, same issue. You cannot cancel added, subtracted items. Those numbers prove that, don't they? You can only cancel multiplied numbers. So we factor, because factoring makes, it makes them multiplied. That's what factoring does for us. That's why we learned how to factor and we use factoring so often, because it makes things multiplied and then we can cancel. So let's do it. So how do we factor these? Well, you remember how factoring works. You've got to do the multiply, add, multiply. So let me come down here. And I'm going to do the multiply, add, multiply. So there's a times dot in here. So I'm going to put 2 parentheses. And 2x times x multiplies to be 2x squared. Okay. And then what multiplies to be 2? Well, 2 times 1. Now I've got it in the wrong order. I'm purposely doing it wrong at first, just to remind you how it works. So is it that way? It's not. Let me check it. So if you come down, notice I haven't put the plus or minuses in yet. I'll do that in a minute. Let me check 2x, 2, x, and 1. Remember how you do first to both, second to both? Remember, you have to check these. These are harder. These kind that have a number in the front are much harder. So 2x squared, 2x, and then this guy goes to both, 2x and 2. Is there any way that 2x and 2x in the middle can make the original middle of 5x? No way. No way 2 and 2 are going to make 5. They had to be 4, not 5, huh? So what does that mean you do to fix it? You switch the order. So let's come back up here. Now I'll put the 1 here and the 2 there. 1 here and the 2 there. Wait, 1 here, 2 there. And now let me check it again. Let's try it again. 2x squared. Now it's 4x, 1x, 2. Now these guys can make 5, can't they? If you make them both plus, you make that plus, that'll do it. Both plus. Do you see how by checking it, I made sure that it really worked to become 2x squared plus 5x plus 2. Check. Everybody see that? That's the deal on these. You have to check them to make sure it's right. So it's 2x plus 1, x plus 2. The order on those back two matters. The order on the back two matters. It's one way and not the other way. And you have to check both ways until you get it right. So there it is. It's plus and plus. When you check it, you can see it's right. So these are harder, these ones with numbers in the front. So how about down here? Well, let's come over here. This one's going to be, again, multiply, add, multiply x times x. Well, it multiplies to be minus 6 with 3 times 2 or 2 times 3, whatever. Now, the order on this one doesn't matter. Why not? Because the fronts are the same. See how the fronts both just have an x, whereas the last one had a 2x and an x. They were different fronts, and so the order mattered who was with whom. But now it's just x and x, so the order doesn't matter. How do they add to be plus 1x in the middle? Sign in the middle goes on the bigger, doesn't it? Right? If you gain 3 pounds and lose 2 pounds, you gained 1 pound overall, didn't you? See that? Now, how about the next one? Over here, again, we're talking multiply, add, multiply, but this is going to be a harder one because we have a 2x and an x in the front. Like that. So, what goes on the back? Well, I'm going to have to check. It's going to be a 2 and a 1 to multiply to be 2. Probably going to be this order right here. Let me check it. So I'm going to check 2x, 1, x, and 2. Okay, so here, let me get a little more room here. So, okay, so here we go. I'm going to check it. So this first goes to both. 2x squared, 4x, boom, boom, 1x and 2. Now, what do we need to make on this one? We need to make minus 5 in the middle. So what signs do they need? They both need negative, don't they? You can see it coming. Minus 4, minus, so they both got to both be negative because that way it's minus 5x in the middle, right? If you lose 4, think about weight gain and loss. You lose 4 pounds, you lose 1 pound, you lost 5 pounds. So they've got to both be negative. And 2 negatives multiply to be positive 2, and that's right, check. That's exactly what we want. So there we go, minus 1 minus 2 is correct. And then on the very bottom, again, multiply and multiply. X times x. What multiplies to be 2? 2 and 1. The order doesn't matter because they just both have x's in the front. They're not different fronts, so the order doesn't matter. Both positive. That way they add to be 3 in the middle. All right, all that work. The hard work on this one is factoring, isn't it? Now we just cancel whatever matches. What matches? X minus 2 and x minus 2. That a little better. X minus 2, x minus 2. What else? X plus 2, x plus 2. And that's it, huh? Looks like that's all that cancels. So then what's left? Oh, everything else stays. So what's left over? On the top, 2x plus 1 and 2x minus 1. And on the bottom, x plus 3 and x plus 1. So that's our answer. That's the leftover on the top and the bottom. Everything else canceled. And so there we go. So this is a long one. So dividing, we have to first step change to multiply, flip the fraction on the right. And then we basically got 4 factoring problems, 2 of them being hard ones that have a 2x squared in the front. So those are harder. You have to check those to make sure everything's right. Get it all factored and then cancel what matches top and bottom. And there's the leftovers. There's our answer.